Okay, 5.1, changes in matter and energy. So here is, we want to see what is the heat, thermal energy, chemical system, and what is those keywords. The thermal energy, the energy available from a substance as a result of the motion of its molecule. So faster the molecule move, the thermal energy will be higher. Chemical system is a set of reactants and product under study. For example, the reactant is C2H2O2, product is CO2H2O, and we want to study that. So it's going to be chemical system. Surrounding, all matter around a system that is capable of absorbing or releasing thermal energy. Let's say your surrounding is air or the surrounding is water. And this reaction is happening there. So it's going to be, if this reaction happening in a tank, the surrounding would be whatever is inside the tank. Or is inside of water, the water going to be the surrounding. So exothermic and endothermic. Oh, heat is the amount of energy transfer between the substance. So heat is energy that is moved from one place to another place. Exothermic reaction is when you have a reaction that releases energy. Endothermic is a reaction that absorbs thermal energy. Temperature is average kinetic energy of the particles in a sample matter. So open system. So when you have open system, both matter and energy can escape. Isolated system, there is no matter and energy cannot escape the system. Closed system. In a closed system, the matter cannot escape, but energy can move out or in. So these are the concepts. So here, you perhaps seen this is Q is equal to MC delta T. Q is the energy is transferred into the substance, is equal to mass of substance. C is heat, specific heat capacity, and the delta T is the temperature change. So if you have a temperature and heat capacity and the mass of the subject, so you can see how much energy was given or taken away from that substance. Well, what is the heat capacity? Heat capacity is the amount of energy in joule you need to give a substance to increase the temperature to 1 gram of the substance, to increase the temperature by 1 degree Celsius. To understand this concept better, imagine you are at the beach, right? So here is the water, here is the sand, right? You have a sun. The sun is shining the same way. The heat is coming from the sun, will shine the same way, the same amount of the sun the heat will be absorbed by the water and the sand. Things that, but when you walk on the sand, you will see that it's very hot and you just want to go to the water and the water is cool. The reason is that the heat capacity of sand is much more smaller than heat capacity of water. This is a small means you need to give it a small amount of energy to increase the temperature of the sand. Is very large means you have to give a lot of energy to water to increase its temperature by 1 degree Celsius. The water is a very key element on Earth because as temperature rises, as the Earth is heating up by the elements, the temperature will not rise and fall much. That's why the life and ecosystem on the sea will be very safe because of that high specific heat capacity of the water. Play very important role. So this is the definition of the heat capacity. Now let's just look at this question. when 600 milliliter of the water, an electric kettle is heated from 20 to 85, make cup of tea, how much heat fall into water? I need to have mass of the water, have volume. So knowing that 600 milliliters, 600 gram, just always remember 1 gram is 1 milliliter of the water. Okay, so I have 600 milliliter means I have 600 gram of the water. So having the heat capacity of the water is 4.18 joule gram degree Celsius. So just keep this one in gram because here we have gram, right? It's good. The delta T is the final temperature minus initial temperature. 85 minus 20 is 65. I have it. I know the equation Q is MC delta T. M is 600 grams. C I have delta T. See, gram and gram cancel. And Celsius with Celsius can just the unit is joule. We can convert that into the kilojoule after we multiply these numbers. 0.63 10 power 5 joule, which is 163 kilojoule, divided by 1,000. Another example, what would be the final temperature if 250 joule of heat were transferred to 10 grams of the methanol initially at 20? So since we know the heat capacity of the methanol, we know the amount Q, and we know the initial temperature. We're looking for final. So T2 minus T initial is given. T2 minus 20 is your delta T. And the mass of that is 10 grams. So you just easily use the equation. Q is given, mass is given, C is given. I just, instead of delta T, you just put T2 minus T20 and bring the MC to the other side. So it's going to be Q divided by MC. You put the numbers, delta T is going to be T2 minus 20, and you just do it in calculator. 20 to the other side will be positive, and the answer for the T2 you can find T final is 28.6. So you can do question number 9, 10, and 11. This is page 302. So you can look at this part that is talking about physical change, chemical change, nuclear change. Physical change, there will be your substance will not change. Just the phase will go under the change. Like this question. So you have a H2 gas, you are cooling that down, and it turns into the ice shown in solid form. So it's released there, you're taking away heat from that. Any phase change, that the material will stay the same. Chemical change will have entirely different, the product will be different than reactant. So here you have C3H8 plus O2 is burning, give you different material, carbon dioxide and water, and the heat will be produced. Nuclear change, when the number of the proton and neutron in atom will change. It's like the uranium-238 will become TH-234. So the number of the electron proton is changed. Third.